Hello, today we're going to use Lewis dot diagrams to determine how ionic bonds form between a metal and a nonmetal. So we know ionic bonds are when there's a transfer of electrons and ions are formed, and these oppositely charged ions are attracted to each other. Let's do an example with magnesium and iodine. First thing we want to do is figure out how many valence electrons each of these have. Let me see. Iodine is in group 17 or 7A. It has 7 valence electrons. So I'm going to put an iodine right here. 7 valence electron. 1, 2, 3, 4. And I'm going to pin mine up 5, 6, 7. We don't start pairing them up until after we have 4, till all the seats are filled. So these 4 spots represent the 1s orbital and those 3 p orbitals that are in this particular energy level. Then magnesium. Magnesium is an alkaline earth metal. It's in group number 2, or 2A, and so that means it has 2 valence electrons. I'm going to put 1, and I'm going to put 2. Now, we know magnesium wants to give those 2 away in order to become stable. It is a metal. So we put 1 here. Now iodine is now happy. It has an electron. But this other one here, what's it going to do? Well, what you need to do is have another iodine. So these will randomly pair 1, 2, 3, 4, 5, 6, and I'll leave that one. I'll put it here, 7. And so this electron will go with this iodine. So how we write the formula, how we know what's going to happen is we count up how many atoms of each element we need to satisfy the octet rule in both the atoms. So I need 1 magnesium. You always put the metal first, Mg, and 2 iodines, I2. And that is the formula, magnesium iodide. And we could double check with the charges. The charges need to be neutral. When we have the transfer here, iodine is a -1. Magnesium is a +2. Let me get the other iodine. Magnesium is a +2. Minus, 2 minuses and 2 pluses. We made a neutral compound, magnesium iodide.